Welcome to Unbound Learning. Our topic today is the binary system, and I'll be teaching you what binary system is and how it works. Some of you might have heard that binary is the language of computers, which is true, but it doesn't mean that binary is something that has been specifically created for use in computer systems. But binary is just a base 2 number system, just like the base 10 or decimal number system that we use on a daily basis. Binary is base 2 because it has two digits, a 1 and a 0, and this system is preferred over other systems because of its simplicity and because binary can be easily implemented when it comes to digital circuitry. Now we'll learn more about binary a bit later, but first let's take a look at a system that we're more familiar with, which is the base 10 number system. It's called a base 10 system because it has 10 digits that begin with a 0, then a 1, then 2, then 3, 4, 5, 6, 7, 8, 9. To have a better understanding of this system, let's perform a few calculations. Let's say we want to add two numbers, 2 and 3. The sum of these two numbers can be represented using the digit 5. Now let's perform another calculation. Let's add 4 and 2. The sum of these two numbers can be represented using the digit 6. Let's perform another calculation. Let's add 7 and 2. The sum of these two numbers can be represented by the digit 9. So far we are having no problems with our calculation, but the problem arises when we try to add two numbers whose sum is greater than what can be represented using our system. Let me show you an example. Let's try to add 7 and 3. Now as you can see, there's no digit in our system that can represent the sum of 7 and 3. Let's take another example. Let's try to add 8 and 3. Again we run into the same problem. There's no digit that can represent the sum of 8 and 3. To solve this problem, let's take a look at an example. Let's say we want to store a bunch of disks in different types of boxes. We have three types of boxes. One is the blue type, which can store a maximum of 1 disk. Another one is a gray type, which can store a maximum of 10 disks. And another one is a red type, which can store a maximum of 100 disks. Let's say we have 9 boxes of each type. We need to store the disks in such a way that at any point in time we can tell how many disks we have without having to open the boxes. Because the blue boxes have a maximum capacity of 1, therefore I'll be representing the blue box as an individual disk. Now let's start storing the disks into the boxes. Right now we have 3 disks, so we can easily store them in 3 blue boxes. And then we can mark it as 3. So at this moment we know that we have a total of 3 boxes with 3 disks in them. Let's say we want to add 3 more disks, so we'll store them in the blue box column. This is 1, 2 and 3, and we'll update the total as 6. So now we have 6 disks. Now let's store 2 more disks in the blue box column. Now we'll update it as 8. Now in this column we have 8 boxes filled with 8 disks, and there is 1 box that's empty. Now let's fill that with a disk. Now we'll update the total as 9. Now if we want to add another disk, then that would create a problem because there are no empty boxes left in this column. So we cannot add another disk to this column. But we know that we have other types of boxes as well, and the gray box can hold a maximum of 10 disks. So what we are going to do is, we're going to take all these disks and then we're going to store them into a gray box. So now we have 9 disks in this gray box, and we can store 1 more disk into this box. So let's do that. Now we can update this because now it contains 10 disks. Now at this point we have one gray box filled with 10 disks, and all the blue boxes have become empty again. So we'll update this and mark it as 0. And we'll mark a 1 here, representing that we have one full box filled with 10 disks. Now let's say we want to store more disks. Let's add 3 disks here. And we'll update this and mark a 3 here. Now we have 13 disks in total. Now we'll add 2 more disks and mark it as 5. Now let's add 4 more disks to this column. And update this to 9. All the boxes in this column are again full, and we cannot add more disks to it. So again what we will do is that we'll take all these disks, store them in a gray box, and then add this one individual disk to it, and the total will be 10. So we'll update it as 10, and we'll also have to update this to a 2, because right now we have 2 full gray boxes that contain 20 disks in total, and we'll update this column to 0. We can keep doing this until we run out of gray boxes. Remember, we can have a maximum of 9 gray boxes. So let's add 9 gray boxes to this column. And let's assume that all these boxes are filled with disks. And this is 9. Now we'll update this. Each of these boxes are now containing 10 disks, and we have 9 of these boxes, so we'll update this as a 9. This represents that we have 9 boxes that are filled with 10 disks each. So at this point in total we have 90 disks. Now let's say we want to store more disks. Let's say we want to store 5 of them. That's 1, 2, 3, 4, and 5. So we'll have to update this to 5. Let's add more disks. 6, 7, 8, and 9. And update this to 9. Now in total we have 99 disks. Now let's say we want to store one more disk. Now again we run into the same problem of not having any empty box in the blue box column. And another problem in this situation is that if we combine these disks and form a box, we don't have any gray box left that can hold 10 disks. So in this situation what we will do, we'll take a red box that has a capacity of 100, and then we'll store these 90 disks in that box. And we'll update it as 90. All the disks that we had in this column we transfer to the red box. Now red box contains 90 disks, and we'll take these 9 disks and transfer them to the red box. And we'll update this to 99. We can't mark this as 1 because this is not a full box. There's still space left for one disk. So what we're going to do, that we're going to take this disk that we're trying to fit into this column when we had no space in this column, and we'll place this disk into the red box. And then we'll update the red box to 100. Also we would mark this as 1 because now we have one box that has 100 disks in it. And in the gray box column we have no box filled with any disks, so we'll mark it as a 0. And same for the blue box column. So right now we have 100 disks that are stored in a single red box that has a maximum capacity of 100. Now let's say we want to store more disks, and we can easily do that because we have enough free space now. And we'll do the same thing of transferring the disks to bigger boxes in case we are out of space in any particular column. So using this system, at any particular point we can know how many disks we have stored without having to look into the boxes and counting the individual disks. And this is exactly how base 10 system works. Now let's get back to our previous example. Earlier we ran into a problem while trying to add 7 and 3. because there was no digit that could represent their sum. Now let's think of this problem as having 7 disks in the blue box column and trying to add 3 more disks to it. Here we have 7 disks, and now we are trying to add 3 more to it. The blue box column can have a maximum of 9 disks, and we already have 7 disks in it, so we can add 2 more. But if we try to add 1 more disk to it, we can't. So as we did earlier, what we will do is that we'll get a gray box and store all these disks into this gray box. And also this additional disk can be stored in it because it has a maximum capacity of 10. And now we can mark it as one box filled with 10 disks. And because in the blue box column we have no individual disks left, so we'll mark it as 0. In this way we can represent the sum of 7 and 3, which is a 10. Now let's solve for 8 and 3 in the similar manner. Let's say we have 8 disks. 1, 2, 3, 4, 5, 6, 7, and 8. And we want to add 3 more disks to it. 1, 2, and 3. Since there are 8 disks in the blue box column and there is a space for 1 more disk, so we'll shift this disk to the blue box column. Now we are left with 2 additional disks with no space in the blue box column. So now we'll have to get a gray box, fill it up with 10 disks, and mark the gray box column as having one box filled with 10 disks. And after doing that, we'll be left with 1 additional disk that we'll have to store in the blue box column and mark it as 1. So that's what the result of 8 and 3 is going to be. Let's clear up some space here and perform one more calculation using our disks analogy. Let's take a blue box, a gray box, and a red box. This is a capacity of 1, this is a capacity of 10, and this is a capacity of 100. And we can have 9 of these boxes in each column. Let's say we have 99 disks. And we want to add 1 more disk to it. Now since this column can have a maximum of 9 disks and we are trying to add 1 more disk to it, so we will have to mark it as 0. Take these 9 and this 1 disk and form a box of 10 and add it to this column. Now the problem here is that in this column we can have a maximum of 9 boxes filled with 10 disks each, and they're already full, so we cannot add another box to this column. So what we're going to do is that we're going to take these 9 boxes and this 1 box and combine them together to form a single box containing 100 disks. So we'll mark this as a 0 and shift this box to this column. Now we have 1 box containing 100 disks, so we'll mark a 1 here. Now let's add 11 more disks to it. And we'll get a total of 111. Now let's remove these boxes and name these columns as 1's place, 10's place, and 100's place. Now here we have 3 identical digits that represent the same value of 1. Although they are identical, but they have a different value based on the column they are placed in. This digit represents 1 and is at 1's place, therefore its value is 1. This digit again represents 1, but since it's at the 10's place, therefore its value is 10. Likewise, this digit represents 1, but since it's at the 100's place, therefore its value is 100. In any number system, there are 3 properties that apply to any of its digits. And those properties are the face value, the place value, and the actual value of the number. The face value is the value that the digit represents. The place value of the digit is its value based on its position. And the actual value of a digit can be calculated by multiplying its face value with its place value. Let's take our example value 111 and let's find the face value, place value and actual value of each digit. This digit represents the value of 1, therefore its face value is 1, and that's same for all the 3 digits. But since this digit has a place value of 100, therefore its actual value is 100. And this digit has a place value of 10, therefore its actual value would be its face value, that's 1, multiplied by its place value, that's 10. So that will give us a total of 10. And this digit has a place value of 1, therefore its actual value is 1. And this gives us a total of 111. Now let's take a look at a few more examples. This digit here has a face value of 8 and a place value of 100. Therefore its actual value is 8 into 100, which will give us 800. This digit has a face value of 8 and a place value of 10. Therefore it will give us a total of 80. And this digit has a face value of 5 and a place value of 1. Therefore its actual value is 5. Let's take a look at another example. Here this digit has a face value of 2 and a place value of 1000. Therefore its actual value would be 2000. And this digit has a face value of 9 and a place value of 100. Therefore its actual value is 900. This digit has a face value of 3 and a place value of 10. Therefore its actual value is 30. And this digit has a face value of 5 and a place value of 1. Therefore its actual value is 5. What I've shown you so far in the base 10 number system works exactly the same for binary or octal or any other number system, with the differences being the amount of digits we have and how the place value changes. In the base 10 system, it will change in an exponential manner like 10 raised power 0, 10 raised power 1, 10 raised power 2, 10 raised power 3, and so on. In binary, it will change like 2 raised power 0, 2 raised power 1, 2 raised power 2, and 2 raised power 3. In octal system, it will be like 8 raised power 0, 8 raised power 1, 8 raised power 2, 8 raised power 3, and so on. Now let's get back to the binary system. We used the disks analogy to understand the base 10 system. Now let's use the same analogy to understand the base 2 or binary system. In the decimal system example, each column could have 9 boxes of a particular type. That was because in that system, the maximum amount we could represent using a single digit was 9. But in this system, the maximum amount we can represent using a single digit is 1. Therefore, each column can contain a maximum of 1 box of one type. So the blue box column can contain 1 blue box, the gray box column can contain 1 gray box, the red one can contain 1 red box, and the white one can contain 1 white box. Now let's say we want to store 1 disk. We can do that by storing it in the blue box column, and then we'll mark this as 1. Now if we want to add 1 more disk, we cannot store it in the blue box column because it's already full. So what we'll do is we'll get a gray box, place these 2 disks into this gray box, and mark it as 2 because it's holding 2 disks at this moment. Now the blue box column is empty, so we'll update this to 0. And since we have 1 gray box that's filled with 2 disks, we'll mark it as 1. And this is how a 2 is represented in binary. Let's add one more disk to it. Now we'll update this to a 1. And now we have a gray box filled with 2 disks, and we have an individual disk in the blue box column. That means we have 3 disks in total, so let's update that. Again, if we try to add one more disk to it, we'll have to combine these 2 disks and form a gray box. But the problem is that we cannot store the box in the gray box column because it's already full. So what we're going to do is we're going to take a red box, and this has a maximum capacity of 4. So we'll take the disks in the newly created box and also the disks that we have stored in the gray box column, and then store them in the red box. Then we can place the red box in the red box column and update it to 4 because now it contains 4 disks. And because the gray box column is empty now, so we'll update this to 0. And the blue box column is also empty, so we'll update this to a 0 as well. And since we have one full red box, so we'll mark it as a 1. That's how we represent the number 4 in binary. Now let's add one more disk to it and then another one. Again, we'll have to get a gray box, fill it with these 2 disks, and place it in the gray box column, and update it to a 2. And since we have one full gray box, so we'll mark it as a 1. And we'll also update this to a 6. Because now we have a total of 6 disks, 4 in the red box and 2 in the gray box. Now let's add one more disk, and we'll update this to a 1. And now in total we have 7 disks, so we'll update this to 7. Now if we try to add one more disk, we cannot do that. So let's get a gray box and fill it up with these 2 disks. But the gray box column is already full, so we cannot add any more gray boxes in here. So we'll get a red box and transfer the contents of these 2 boxes into the red box. So now this will have 4 disks in it. But again, we cannot add this box to this column because it's already full. So now we'll get a white box. Now we'll transfer the contents of this red box and this red box into the white box and place it in the white box column. And then update this to 8. Because now it contains 8 disks, and also mark a 1 here. Now all these other columns are empty, therefore we'll mark them as 0. And because we have 8 disks in total, we'll update this to 8. And that's how you represent the number 8 in binary. Let's try to add a few more disks. Again, we'll get a gray box, transfer these 2 disks into this box, and place it in the gray box column. Now we'll add this disk here, and again get a gray box, fill it up with these 2 disks. And because we cannot place it in the gray box column, now we'll get a red box. Transfer the contents of these 2 gray boxes into the red box and then place it into the red box column. Mark it as a 4 and then update the value here to 1. Now we have 12 disks, so we'll update this to 12. And that's how you represent 12 in binary. Let's take some random binary numbers and learn how to figure out what their value is in decimal. For this, we are going to use the concept of face value and place value, just like we did in the decimal system. This digit here has a face value of 1 and place value of 16. Therefore, its actual value would be 1 into 16, which is 16. This digit here has a face value of 1 and a place value of 8. Therefore, its actual value would be 8. This digit here has a face value of 0 and a place value of 4. And the actual value would be 0 into 4, which is 0. So we don't need to write it here. Same is the case with this digit. This digit has a face value of 1 and a place value of 1. Therefore, its actual value is 1. Now we'll add these up, and that will give us the value in decimal for this binary number, which is the number 25. Now let's do another example. This digit here has a face value of 1 and a place value of 32. Therefore, its actual value would be 32. This would have an actual value of 0. Therefore, we don't need to add it to our sum. This digit has a face value of 1 and place value of 8. Therefore, its actual value is 8. And this digit has a face value of 1 and a place value of 4. Therefore, its actual value is 4. And these two digits have a value of 0, so we don't need to add them to our sum either. If we add this up, we get a total of 44. And this is the decimal value of this binary number. That's it for this tutorial, and I hope you understood the concepts well. If you have any questions or suggestions, then please drop a comment in the comments section down below. Thanks for watching.